Intersection of skew lines with a plane. This question is extremely important for you to understand. The question here is, explain if it is possible for skew lines to intersect a plane in following ways. So the number of ways are 2 points, 1 point, 1 point and 1 line and 2 line, right? I'd like you to pause the video, answer the question, and then look into my answers. Also remember, once you take a choice, let us say you say 2 points not possible, you have to give a reason. If you say 2 points is possible, you have to explain and give a reason, okay? So it is expected of you to make kind of a sketch to show your solution or give a condition when is it possible or when is it not possible, correct? So that is how this question needs to be answered, and that will help you to understand what skew lines are and how do they intersect with a plane, right? Now here are my suggestions. Now when we are considering skew lines, we know two things about skew lines. What are, after all, skew lines? Let's first write on that. So when we say skew lines, what do we mean? Skew lines means lines are not parallel, right? Not parallel. This is first thing. And second, they are contained in parallel planes. They are contained in parallel planes. So these are the two things which we know about skew lines. Whenever we say skew lines, we are talking about two lines at the same time. And these lines are not parallel. Second, they are contained in parallel planes. Now, what do I understand by contained in parallel planes? So let me explain you that part, right? So let us say we have a plane here. So I'll draw first two parallel planes, right? So we have a plane here, right? And then we have a plane here. So, so these two planes, imagine that they are parallel. So the planes we are saying are parallel, and we'll just call these planes as pi 1 and pi 2, right? These are my two planes, right? Now in these planes, we have two different lines. So if we have lines in the planes, they are skew lines since they are parallel planes. So let me draw one line which is kind of like this, right? So it extends forever since as the plane also extends. And here I'm drawing a line which is kind of like this, right? As you can see, these lines are not parallel. So I'll name this line as L1 and I'll name this line as L2 so that it's easier for me to communicate with you. And the planes are pi 1 and pi 2. So we have lines that are not parallel. That means they have direction numbers L1 and L2, which are different, right? Which are M1 and M2. But planes pi 1 and pi 2 both have same normals, right? So the normals are same. So that is the situation. Now we need to understand how can they intersect at 2 points. First question is, can they intersect or not? Second, how can they intersect, right? Now if we consider another plane here, which is kind of, let's say any plane here, right? So I'm just drawing some plane here. Let's say this is my plane. And I'm writing this plane as pi 3. Now in this case, as you can see, what I can do is I can extend my lines, right? So if I extend my lines, this as the plane extends, the lines also extend, and planes can extend all the directions, right? So this line can extend and it can go through this. Do you see that? So I can extend my line, there it goes, and that's the point of intersection, and that's how it goes out, right? And this line can go through it like this, right? So there it goes, that's the point of intersection. I should have drawn that dotted to show it going inside. And so there are two different points, right? So we say yes, that is true. That is true, and this particular plane is not parallel to either. So in this condition, we have plane pi 3, which is not parallel to pi 1 or pi 2 or line 1 or line 2, kind of, right? So, or not along, as it should say, not parallel to pi 1 or pi 2, right? So it's any other plane, right? One. Second thing, which is this plane does not contain the line, right? So that is first thing. and second is it does not contain L1 or L2, right? Or L2. That means the lines are not totally contained in that plane, right? In that case, it intersects in 2 points. So as you are now understanding, the critical point for us is that contain, right? So if the plane contains a line, then the intersection will be a line, right? If the other plane does not contain the line, then it will have an intersection with a line as a point, right? That is how it is. Now, here it is. Next is 1 point. Is it possible or not possible? Now, for this situation, what I can take here is that I can take a plane which is parallel to one of the lines, for example. So if I take a plane which is parallel to this line, for example, right? So if it is parallel, let me draw a plane which is parallel to this, but it is not parallel to the other line, right? So let's say this plane which we have here. Now, for this plane, since it is parallel to the line, this line will never intersect, but this line will extend, right? Will extend directly and then intersect, right? Into that point, right? So that is, say this is my plane pi 4. Now as you can see here, that if I have the answer is yes, it can intersect at 1 point, and here what we have is another plane which is parallel to line L1, one of the lines, right? But not parallel to line L1, right? Since these two lines are not parallel, if it is parallel to L1, it is not parallel to L2. Do you understand? So that is the advantage we have taken of this condition. Do you see that? So my plane is parallel to one of the lines, but not to the other line. In that case, the plane is parallel, so it will not intersect with that particular line, right? Now imagine a plane which a line on this paper and a plane slightly above it, right? So this line is never going to intersect the plane which is slightly above it. So it can intersect at 1 point, which I am showing by this pi 4, correct? Now the third condition is 1 point and 1 line. So how is it possible for a plane to intersect at 1 point and 1 line, right? Now for that, think like this. If I take a plane which is along the line, that means it's kind of a pencil plane, right? Do you understand pencils? So pencil plane, so it has this line as common. For example, or we can take this line as common. For now, I'll take this line as common, right? So if my plane has got this line common, right? Let me use a different ink here. So this line is common to my plane. So this is a portion of my plane, right? So we have a plane like this. Do you see that? So if I have a plane which is going like this, where this line is common as such, you can see then it intersects along the line, which is line L2, and the other line goes through it with a point, right? So this is also possible, right? So that I have shown with plane 5, right? So what is so special about pi 5 is that, so we have a plane along one of the lines, right? One of the lines. So that line in this case was L2, which I have shown here. If plane is along one of the line, then it intersects on one line and a point. The other line will intersect at a point, correct? That is how it is. Now the last condition is 2 lines. Now I cannot have a plane which will be along this line and that line. So that is not possible for me, right? So therefore, this is not possible, because if I align it along this line, then it is not going to be along that other line, correct? So that is not possible. So the last condition here is not possible. So this will say not possible. Not possible. But the first 3 are. So you should understand, now we had discussed in our chapter how one line intersects with a plane. Now this is very interesting. In a space, R3 space, how a skew lines. So when we say skew lines, we are considering 2 lines at the same time, which are not parallel, but which are in parallel planes. How do they intersect the third plane? What are all the possible scenarios? So all possible scenarios are that the skew lines can intersect the third plane in 2 points, in 1 point, or 1 point and 1 line. But they cannot intersect in 2 lines, right? I hope that point is absolutely clear. Thank you.